Hello everyone, welcome back to our DLLM show. Today we have a very special guest, Shan Srivardhan, an experienced DevOps consultant from Singapore, who will be sharing his expertise on using Terraform to start a Kubernetes cluster. So before we start, Sean, could you please give some kind of an introduction about yourself? Also, he's my brother. So up to you, Sean.
Yeah, hi Shaman, hi Ravindu. Currently I'm based in Singapore and I'm working as a cloud and DevOps professional. And I'm mostly involved in these cloud migrations, setting up these applications, infrastructure in cloud, and then applying DevOps concepts to improve the processes. Yeah, so that's my main area. Uh, yeah, so I,
Yeah. So Sean, let's say I really need to understand this with some layman terms. Could you please explain what is Terraform in few sentences?
So to understand the Terraform, we have to understand what infrastructure as a code is. So traditionally, infrastructure was managed using these user interfaces. So I would say web front ends. So in the context of the AWS cloud, so usually we can use a public cloud service provider to host our workloads. So we would be creating resources like virtual machines and file systems, object storages, load balancers. It could be caching services. There are like different services. So initially, the services were used to manage using the web front end. So every time somebody had to manually use the AWS console to create the resources, and then when it comes to subsequent management tasks, they have to follow the same procedure. And now we have this infrastructure as a code concept, where the infrastructure is defined as a code, and then that code is used to provision the infrastructure initially and to do the subsequent management. So there are different languages or different tools that we can use to manage infrastructure as a code,
Oh,
and Terraform is one
mhm.
of those.
So if I understand, yeah. So if I understand this correctly, it's more of a like we don't need to use the AWS console, but we kind of programmatically turn on these servers and everything, right? That's Terraform. So it has so is it something like Pythonic, or like it has its own programming language?
So when it comes to Terraform, so Terraform as a programming language has its own declarative syntax. So as all other programming languages has its own syntax, Terraform also has its own syntax, which is a declarative syntax. And yes, as you said, for the fundamental management of the infrastructure,
Okay.
Terraform is used. Yes, that is correct.
Because there is YAML as well, right? I've heard Terraform is mostly YAML, but
Uh,
do you code in YAML or is there another like programming language?
okay, so as far as I can remember, there are two formats. One is HCL, if I'm not mistaken. The other one is JSON. So I'm not pretty sure about the HCL one, but they have two forms of syntaxes. Uh, but I would say HCL is
Okay.
it's not like exactly similar to YAML, but it's kind of similar. I mean, both are declarative languages, right? Like even when it comes to YAML, it's a declarative language. But I can show you, like, since my screen is shared, right?
Yeah. We'll definitely. Yeah.
No,
No, you
you're not.
you 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 haven't shared. Wait, Shan. We have a couple of more questions.
Okay.
So just in few sentences. Now, because in today's topic we are going to start a Kubernetes cluster with Terraform.
hmm
So to a newbie, how could you explain about Kubernetes or
Uh,
the concept?
yeah.
Do we
So first,
assume that people know
hmm.
about containers?
That's a good question. Yes.
Yeah. So I'll also explain the
Yes or
containerization
no? What
part.
do you mean?
Yeah.
You
Yeah, I would say like we can't we shouldn't assume, yeah, because my knowledge in that is slim to none actually. Yeah.
Okay. So let me try to explain in layman terms. So let's say you have a Java application, right? So you have a Java application. So traditionally, what you would do is you will build the Java application. So once you build the Java application, you will get a Java file or a WAR file, and then you will have a virtual machine, and you will use that deployment artifact, which is the Java file or WAR file, and then you will deploy that deployment artifact on top of your virtual machine, and then you expose the application to your users. I mean, that's the traditional approach. So application is quite independent, and so you can't simply run an application alone, right? So you have to have the underlying runtimes. For example, to run a Java application, you have to have Java running, right? A JVM. So likewise, these runtime components and these configurations, or like most of the things are actually decoupled from the application. So containerization is like once you have an application, you kind of bundle the application and the dependencies. So when I say dependencies, the dependencies are the runtime. It could be configurations. It could be libraries. So you bundle the application and the dependencies to a single package, and that package is called the container. So this is the very basic idea of containerization. So once you have your application, you would containerize it, and then the container you can deploy on a container platform. So Kubernetes is actually a container orchestration technology. So what I'm trying to say is, let's say if you have like hundreds of containers, you have to manage those, you have to orchestrate those. So Kubernetes is just used for the orchestration part. So when I say orchestration, so you might want to scale your number of application instances as the traffic to application is very high, and you might want to scale it down when the traffic is low, or you might want to enable some self-healing features in your application or load balancing features. So Kubernetes provides you those. So those are the features of Kubernetes as a container orchestration technology. But containerization is basically bundling your application and the dependencies. And
Yeah. So when you say orchestration, I'm thinking like one way what you so what one way you said was like increasing the number of containers or decrease the number of containers, but does it have anything to do with like communication between the containers or not really?
Yeah, so even communication between the containers is something that Kubernetes can take care of. For example, let's say you are running a microservices platform with different containers, right? And so you might not want to enable your applications to communicate with all the other applications, all the other microservices in the microservices platform, right? So in that sense, I think Kubernetes has some control. So I would say yes. So it's also related to communication, but not only communication. I mean, communication scaling. It could be self-healing, right? For example, let's say when your application crashes, you might want your application to automatically recover without any manual intervention. So that's also again a feature of Kubernetes.
Okay, so if I understand this correctly, it's more like say you have several containers, let's say, and you need to kind of let's say even the same app, but uh, according to the demand, you might need different number of resources, right? Like let's say different number of EC2 machines or something. So Kubernetes can takes care of that kind of a thing.
Yeah, so like if I try to like explain a practical scenario, right? So let's say we have a CRM application, a customer relationship management application, and then in a CRM application we have applications. I mean, oh, like I would say we have microservices representing certain domains. Like a customer could be one domain, order could be another domain, and payment could be another domain, right? So likewise, inventory could be another domain, and so what would happen is inside a Kubernetes cluster, you will have applications representing all these domains. You will have like one container, one set of container for to handle your customer domain, another set of containers to handle your order domain, another for inventory, another for finance, likewise. And you can actually independently manage these containers, manage the communication between these containers. For example, right, customer containers might want to retrieve information from the inventory domain, but the set of customer containers might not want to communicate with the finance domain, right? So these communication aspects also you can control. So that so when I mentioned previously, I mentioned about auto healing capabilities, right? So sometimes what happens is when a container runs for a long time, it might be possible that it crashes for some reason, right? And in that case, it's good that if you don't want to manually intervene and resolve the issue, but if it automatically resolves, right? If it automatically recovers itself, that's actually beneficial, right? So that's another feature that Kubernetes can enable.
Okay, I guess I kind of got the idea definitely what is Terraform and Kubernetes, because I've seen a lot of memes related to Kubernetes. They say it's kind of a messy thing, you know. Some people would really can get lost trying to figure Kubernetes out, and it's kind of complex as well, right? So just I need a quick answer for this. I know this is not our topic today, but what's your gut feeling are we moving away from Kubernetes for easier systems or like methods, like I would say like easier ones, you know, like a more abstract services, or like are there any kind of alternative easier methods right now?
I would say I've seen both. For instance, right? So Kubernetes is more like an open source technology. So the companies who focus on the portability, for example, like today you might be using the AWS cloud, and next year you might want to move your workloads to the Azure cloud, and you might want to have some consistency with your on-premises infrastructure as well. So for people with for companies with those needs, they can use Kubernetes, which is an open source platform. But on the other hand, right, if you want to get rid of managing the Kubernetes platforms, and if you want to get rid of the overhead, you can choose these serverless services or proprietary platforms. Like when it comes to AWS has ECS, which is a proprietary container orchestration and management platform. But I mean, as far as the portability is concerned, I would say it's a little less compared to Kubernetes, but the management overhead, operational overhead is you can get rid of those, like when you move to a serverless or proprietary platform. So I've seen both actually. So moving into Kubernetes and moving away from Kubernetes.
Okay. All right. I think we should definitely have a separate discussion on Kubernetes and more of like a simple application, because it seems pretty fascinating thing for me. But yeah, let's actually um, start our main topic today, to see like how we can use Terraform to kind of start a Kubernetes cluster. And yeah, Sean, it's up to you. You can share your screen and walk us through the code. Yeah.
Yeah, sure. So let me share the screen. Okay, so hope you guys can see my screen. Let me know once it's visible.
Yes, perfect.
All right. Okay, so basically in this demo, what I'm going to do is uh, first, I'm going to provision the infrastructure. So when I say infrastructure, so here I'm using the AWS cloud, and I'll be provisioning some infrastructure to host an application in the AWS cloud. So I'm using a Java application, and before the deployment of the application, I'm provisioning the infrastructure. And for the infrastructure provisioning, I'm going to use Terraform. So when I say infrastructure, so in the AWS cloud, first of all, I have to have a network, right? So I'm going to provision the network, and then I'm going to provision the EKS cluster in the AWS cloud using Terraform. and once they are ready, I'm going to run the application. Now, basically, I have a simple Java application. I'm going to dockerize the application and create a Docker image, and I'm going to use that Docker image to host the application inside the Kubernetes cluster as a container. So that's the overview of the demo.
Yeah. Can I ask a quick question?
Yeah, sure, go ahead.
So you said like you need to have a network. Network means like the connection.
Yeah, so basically,
like internet, or I mean,
okay, it's not the internet. So in AWS, so for you to deploy your Kubernetes cluster or a EKS cluster, you have to have an underlying network. So network and a subnetwork and some IP addresses associated with the network and subnetwork, right? So usually, like all the resources will be created inside the network. So that's what I'm trying to say. So let me show you. So
like a local area network type thing.
Yeah, a virtual
what
private
type of
network.
a network?
Okay, let me show you.
I said like a local area network type thing, like LAN pod.
Yeah, not
like
exactly.
All the computers, all the services inside the network need to be connected together. Okay.
Yeah. For example, like in the Kubernetes.
Sorry, we don't know these jargons. That's why we are asking these dumb questions.
Yeah, so this is my AWS account, and so I'm in the Singapore region, and so here I have a default network. So the thing is, like now if I'm to create a Kubernetes cluster or EKS cluster, I have to have an underlying network. So VPC stands for Virtual Private Cloud. So as a part of the yeah, Ravid, go ahead.
Okay, I guess like so in companies we usually have this kind of a thing, right? For the entire company.
Yeah, definitely. So
like
so usually
kind of
before
have this VPC, is it?
Yeah, that's right. So you will have the VPC, and when you go inside the VPC,
or it can be for every.
Sorry guys, I think my connection is a bit slow. Yeah. So inside the VPC, you have a few subnets. So there are 3 subnets. So basically, the virtual private cloud, so this CIDR range, this IP range is divided to 3 subnetworks. And so whenever you want to provision a resource, generally we provide the network and the subnetwork inside which the resource is going to be provisioned, generally. Okay. So let me come to the Terraform script.
Okay, I get it.
Okay. So now let me come to the Terraform
so Ridu, I think it's more like, because we always think all these network connections and other things related to the EC2 instance. This is more like, the general, right? Like the general network, as you said, like it could be like where everything is connected. So for each, if since this is a private account, that was your network, right? That were that were your parameters related to that.
Yeah, exactly. So that was my private network.
Okay, cool. All right, over to you.
Okay, all right. So here, so let me show you my Terraform code first, right?
Two more steps.
Okay, so what I'll do is so I have the Terraform code in my Git repository. Let me just clone it first.
I assume everything before this is going to be edited out. So.
No, it's okay. We are not going to edit anything.
I think you should.
Yeah, I just
I
removed it
wish
first.
I have enough time.
All right. So let me come here.
Yeah.
Okay. So let me just show you the Terraform code that I have first. All right. Yeah. So this is my Terraform code. It's a very, very simple code. I haven't followed any best practices or anything. So here what I'm doing is first I'm creating a VPC, the network and the subnet. So just the network and the subnetwork is not sufficient. I have to have an internet gateway, some route tables, route table associations, IPs. So all these networking resources I have defined here. So this is the Terraform code, and this is the syntax tree. So you asked, right, if the syntax is
so this looks more
YAML or not.
Oh, okay, no, it's not.
Yeah. So here in this case,
Okay.
I have used the
For me, it's
Terraform's own
gibberish.
syntax.
So
it's like a language, eh? It's like Terraform language.
It's like a mix between JSON and YAML.
Yeah. So this, I think, if I'm not mistaken, this syntax is called HCL, which I'm not very sure. But if you want, like, I think you also have the option of writing the same code using JSON. And so, for example, right, this is your network, and you can provide this cider range for your network. And once you have your network, I'm going to create.
So are those stuff? Are they like you have to use those names? Like which ones are like user configurable or like?
Okay, so some actually logical
first line
names.
creates a resource called AWS VPC called demo.
Okay, let me interpret it. Yeah, let me try to interpret it.
Yeah.
So these first 8 lines creates an AWS network, and the demo is the logical name. So this demo is not going to appear anywhere in the AWS cloud. It's the logical name, and AWS VPC is actually the definition. Okay. So before that, so I'm using something called providers here, and I'm using this AWS provider. So this is where I tell Terraform that I'm going to use this Terraform code to provision resources in the AWS cloud. So for instance, right, if I want to provision some resources in the Google cloud, I'll be using the Google GCP provider instead of AWS provider.
Yeah. Is that always in a file called providers.tf?
Not necessarily, but usually we do that.
So
okay.
Okay, and
just a quick thing. How do you? Is there like a function in Python? Like how do you call that part? So it seems like it's a so. How does it get called? This providers.tf.
Yeah, so basically how this works is, right, so this entire code is written using a declarative syntax, and once you execute the Terraform code, the Terraform will internally invoke the APIs that belongs to the AWS. For example, right, what happens is the Terraform will interpret, okay, here I'm supposed to create a network, a VPC. So Terraform will internally invoke the APIs that belongs to AWS to create the network. That's how it works, right? So this declarative syntax gets decoded, and then the relevant APIs are being called. That's how it works internally. Are we clear?
Okay, so if I kind of yes, yeah, I think if I put it to more Python, it's more like a hook function where it can like when we change something, it gets called somewhere like somehow. So if we kind of go back to the kind, how can I say, go back to the order, how this would get how this would get initialized, like what
Could
is
you
the
run
first.
a command in the
Yeah,
terminal?
let me
Yeah, which
show that
file,
first.
I'm asking
Let
which
me show
file
that. Okay,
would
let me
run
show that
first.
first. Okay.
Yeah.
So now I'm inside the Terraform. So this is the location where I have all my Terraform configuration files, right? And here, first of all, I have
maybe
to.
you can use clear.
Okay. Okay. So first of all, I have to authenticate with the AWS Cloud.
He's not a clear person.
Okay. Okay. I think I'm using my. I have to log in. Okay. I created a workstation.
You don't
Okay.
have.
Okay. What I'll do is. Hold on for a second. I created a workstation. This is my local machine. I'm using the terminal of my MacBook. So let me just log into my let me log into my
like a virtual
workstation.
machine, right?
Yeah. So this is my workstation. So let's see if it works. Okay. So now I'm inside my workstation. So this workstation also this workstation is also hosted in the cloud. Okay.
Yeah. You can probably clear here as well.
Okay, sure. Yeah.
And then Shaman, you can start another.
Okay, so let me go inside infra. Okay, so now I'm inside the location where I have all my Terraform configuration files, right? And
yeah,
I have to authenticate with the AWS Cloud first, because this is just a virtual machine, and now this virtual machine is going. I mean, inside this virtual machine, I'm going to execute the Terraform script. So this virtual machine should be able to authenticate with AWS and invoke AWS APIs, right? So first, I'm going to make sure that authentication is in place. So to do that, I'm running this command. Okay, so we are authenticated. Actually, I authenticated earlier. So I'm authenticated as a test user in the AWS cloud. So if I go to the AWS cloud, I have a user called test user. It's already there.
in your IAM.
Yeah, that's right. In my IAM under users, it's already there. Yeah, under users, I have the test user with all the privileges required. So now what happens is I have certain permissions that I have assigned to this test user. And when I run the Terraform script here inside this virtual machine, the Terraform will have all the privileges that this test user is assigned with already, okay, to provision the resources. Okay. And first of all, I have to initiate Terraform init. So what happens is once you initiate the relevant libraries or these provider related configurations, everything is downloaded. So we see like some provider plugins are downloaded to this local workspace here, right? And once it is once this initialization is performed, then there's a command called apply, right? So once you run the apply command, first you are given a plan. So basically this apply is the execution command. Okay, so now I got a plan. So this shows me what are the resources that are going to be created in the cloud. Okay, so let's just run through this quickly. So I'm creating a Docker registry. I'm creating an IP. I'm creating the EKS cluster, and the cluster has to have a node group, right? So in an EKS cluster, there are two planes: the control plane and the work node. So this one is the control plane, and this is for the node group, and some IAM roles that are required for the functionality of the cluster. And then yeah, all these are related to IAM. And this is the networking part: the internet gateway, the NAT gateway, and route table, all these, right? Some route table association, some firewall. So all these are required to run the EKS cluster. I mean, it's not necessary. You can also use the default settings, but I just created this explicitly. And if I'm good with the plan, still these are not created. Okay, let me just run this. So I can go ahead and enter yes. Okay. And now Terraform, right? So under the hood, Terraform starts invoking the AWS APIs to create the resources. So this will take like about 5 to 10 minutes. And after 10 minutes, if I go and see in the console, I should be able to see all these resources: the network, the EKS cluster, the control plane, and the work nodes, and these those internet gateways, NAT gateways, everything that I showed. So now they are being created. I think this answers your question also.
Yeah. So if I understand this correctly, how I think is, yeah, you need to have this repository of Terraform. You need to have certain set of files. In those files, you need to do some configurations, and then once you do the Terraform init, it just encapsulate everything, and yeah, just yeah, it get applied, right?
Yes. So once you run the Terraform apply command, yeah, that is when exactly Terraform calls the AWS APIs to provision the resources.
So my question is more programmatically. So that's when we kind of use those files you just showed, right? In your in
Yeah, exactly. That's right. So what I'll do is, like, while this is being run, right, let me just switch back to my Terraform code. So I have a few files. Actually, this is not the best practice. So usually what we do is we modularize the code, right? So we would have one module for networking. We would have another module for the EKS cluster, and then we'll have one main configuration file inside which we invoke the modules sequentially to provision the resources. But here I'm not making use of modules, but this is just a plain code, Terraform code. And so we already ran through the networking part, right? So this is the networking part, and then these two files corresponds
so
to.
does the Terraform apply command, does it basically look for all the Terraform scripts in that folder? Like, it doesn't matter what the names are, it's just like, give me all the Terraform scripts and then apply them.
Yeah, that's right. So Terraform, yeah, the executor will actually look for all these t.tf files, and the yeah.
So this is really kind of functional, right?
What do you mean functional?
Like functional, you because maybe like it does load everything as functions or something. I don't know, like everything is in files and looks for all the t.tf files and grabs
runs them.
whatever in those files,
Yeah, and basically runs the file, right?
Yes.
Yeah, that's right.
Because yeah.
Okay. But I would say, like, this would not be the structure that you would see like in an actual Terraform code. So you would probably see one directory for modules and another directory for your actual configuration. And inside the actual configurations, you will see files invoking your modules with the parameters. And so we can kind of take out the variables, which is a good practice, right? So we would not hard code anything. But in this case, I have hard coded values. But usually what we do is we would not hard code anything. We would have placeholders or arguments, and then we would define the variables separately. And so we will use the variables files, and there's another file called terraform.tfwas. So we'll use those two files to kind of define and declare the variables. That's what we do. And we can have an output.
Just an intro. Yeah, just finish it.
Yeah, so this is the last file, which is the output file. So where we can kind of define the outputs of the execution. So for example, let's say you want to spin up a virtual machine, and you want your Terraform script output to show you the public IP address of that virtual machine. So for that, you can use this outputs feature of Terraform.
Yeah, just a quick question. Imagine if I rename that file as output slash output dash 2 or something, this code won't run, right?
Okay, I haven't tried that, but I think as long as you have this .tf extension, all the files will be included in the compilation and the execution.
Okay. So just a quick thing. So I think this is really pretty much similar to how Airflow works. So in Airflow also you can have different folders for different tag. It doesn't matter. Like what it will do is it will load all these Python scripts and generates those tags. Yeah, that's now I get it. Yes. So this is more like it it doesn't matter the order or something. It will so why we need to kind of divide them into these files is to make it nicer, right?
Yeah, for human readable.
It's a good practice, right, Sean?
Yeah,
Otherwise someone could put everything in a one file as well, right?
Yeah, that's right. Okay, so what I would do is
and this output file format is slightly different, I guess. The format.
Yeah, I mean, it's the same. Yeah, it's slightly different because we have the keyword output, and so this locals is actually a feature of Terraform to kind of so inside this block you can kind of do those integrations, not integrations actually, but how to say that, like you kind of consolidate certain values, and you can define a complex value. So what I will do is, right, so far we are focusing on infrastructure, and still the script is running.
Yes.
And once the execution is completed, you will have your infrastructure ready in the AWS cloud. And the next part is the workload deployment, right? So I'll also run through the workload deployment.
Yes.
So as far as the workload deployment is concerned, so what I'll do is I'll first show you how we are going to deploy the Java application without containerization, no containerization, and then I'll containerize it and run it.
That means no Docker.
Do you want to clarify what the workload deployment is? So what we did was create the infrastructure that will run the code, and then we're basically copying the files that, not copying the files, but creating containers. So the Terraform script doesn't create the containers.
Yeah, that's right. So in this demo, the Terraform script will only work until the creation of the infrastructure. So when I say in the infrastructure, it will create the network, it will create the EKS cluster. That's all. And in this demo, I have planned to manually deploy the workload. So when I say workload, it's the application actually. But I can't simply deploy the application. First of all, I have to containerize the application, right? Because if you are to deploy an application in a Kubernetes platform, you have to have a containerized version of your Kubernetes of your application. So which is what I'm going to do next.
Okay.
Okay. So, but to better understand the containerization, what I would do is I'll deploy the application without containerization, and show you how it works. And then I'll deploy the application. I'll containerize the application, but without orchestration, right? Without Kubernetes, I'll run the container as a second step. So no Kubernetes involved, but still the application is running as a container. And thirdly, I'll deploy the application on top of the Kubernetes platform, which is EKS in this case. Okay, so that is where the orchestration of Kubernetes comes into the picture. So I'll be running through like three phases. All right. So while waiting for this to happen, let me just I think I have to use the same virtual machine. So what I'll do is let me try to open up a duplicate terminal. I think there's an option right now, so
Yeah.
not very
While
familiar with
while
this.
he's doing that, Ravidu,
Yep.
I have, so he said like EKS cluster, right?
Mm.
Sean, you can continue your thing.
Mhm.
So, what did you understand by that, like EKS cluster?
Elastic contain Kubernetes service.
Okay.
Is it?
Elastic Kubernetes cluster.
It's the
That's right.
AWS platform for Kubernetes, right?
Okay. So
Yeah.
what we have done right now is mainly we have kind of initiated the cluster thing, but
Yeah.
uh, it's like, so just a quick question. So while doing so, did we did we kind of initialize it with how many pods or something? No, right? That's why it's elastic, right? Do we need to give some values? What is the max number of pods or min number of things?
Yeah, maybe I can answer that question, Shaman. So
Yeah.
here we are creating the Kubernetes cluster. So just now it's completed. So let me go to the
Mhm.
terminal and show you. Okay. So now this is my
Mm.
AWS console. So firstly, right? So Kubernetes is an open source technology, and so you don't have to have a cloud to create a Kubernetes cluster. So even if you have your on-premises servers, then you can use your on-premises virtual machines to create a Kubernetes cluster. But AWS has their own Kubernetes platform offering, which we call EKS, Elastic Kubernetes Service. So Google Cloud has their own Kubernetes offering, which is GKE. Azure Cloud has their own offering, which is
Okay.
AKS, right? So likewise, we are using AWS offering of Kubernetes, which is EKS. So let me go to the EKS section. Now we should be able to see the cluster which is running. Okay. Now here I'm inside Elastic Kubernetes Service section and Terraform EKS demo. So this is the one we just created, and it's running Kubernetes version 1.27, right? And as I said before, there are two planes. One is the control plane, and the other one is the worker nodes. So usually AWS take care of that control plane, and I have two nodes for the worker nodes. So these are just worker nodes. Still, no application is running inside the Kubernetes cluster except for default applications. For example, DNS is a default workload that is running inside the Kubernetes cluster. And there are some default services like
DNS,
kubectl.
did you say?
Yeah, so they have
DNS.
cube. They have something called kube DNS that handles the DNS
Okay.
resolution, and they have
The
another service
internal.
called kubeless.
Okay.
So okay.
So
Sean,
those are
quick
yeah.
one. So desired size, you had you had the parameter, right? When you were coding up the Terraform.
Yeah, let me show you. Now desired size is 2 here, right? So meaning to say, I have two work nodes. Right?
Yes.
And so if I go to EC2 section, I should be able to see those two work nodes. But they are managed by AWS. I mean, I'm not directly managing these two EC2 instances. So workstation is the one where I'm running
So
all those scripts.
it's like
These two.
Yeah.
So it's more like this worker. Sorry, no, yeah, not the worker. Like what did you call that? Worker nodes, right?
Worker nodes, yeah.
So those two nodes are kind of default, or while starting up the Terraform thing, you had to kind of initialize them, like more like put a parameter two or something. That's
Yeah,
what
it's
I'm asking.
okay. It's not default. So it is defined here in this file, inside this file, EK's worker nodes. So if you see here, right? So I have mentioned for the node group, the
Okay,
name
get
is
it.
demo and desired size is 2. And I have provided a min size and max size.
Okay.
So here what I'm trying to say is,
Yeah.
so let's say you schedule your first application. So two nodes can handle your application pods or containers, right? And when you schedule your second application, still two nodes can handle the load. But if you are scheduling your third application, if you are running your third application inside the cluster, maybe the initial two nodes can't handle the load. In that case, there's a requirement for a new node to be added to the group, right? So that's where like we can automatically scale in and out this number of nodes.
Yeah. Can you scale to 0?
Scale to 0, I think that's not possible as far as I remember. But actually,
yeah,
those
I
are
can
straightforward.
answer that because I can answer that because it's not possible until the most recent version. Because I wanted to do this because when it comes to deep learning training and all, you don't need sometimes like more than one node, right? Because it's just training. So it's because training is not, I would say, unless or otherwise you use something called model parallelism, you don't need to have a bunch of clusters. So I guess in the most recent version you can put 0. Otherwise you can't. I think.
And does it all have to be the same EC2 type instance?
You asking from me?
Oh, Sean.
No, right?
Does it all have to be medium, or can it be a mix of extra large and medium and whatever?
Yeah, so here, right, in this case, I'm just using a single group. So like, let me just switch back to my console, right? Okay, if I go to EKS, so it doesn't have to be, but like you can have multiple groups, and inside a single group, you can have multiple workers. But as far as I remember, inside a single group, all the workers have to be of the same type. But in between the groups, the specifications of worker nodes can differ. But this is just one way of creating the EKS cluster. But now they have a more serverless option called Fargate. So under Fargate, you don't even have the visibility on to these worker nodes. So you will be like simply scheduling your workloads as pods, but you will not even see the EC2 underlying EC2 instances representing the worker nodes.
Wow.
But I didn't use the Fargate option in this case, right?
Yeah,
that's good. That's good.
Yeah, actually, like if you really want to focus in your application, I think you should. I mean, like maybe even in a development setup, you should use the Fargate profile or Fargate option. Okay, but let me show you, right? So when you create a cluster,
right? FARGATE.
Yeah, let me show you. So now, if you want to create a new cluster, right? Let's say use this cluster to. Okay, so somewhere, I can't remember exactly. So there's a configuration somewhere to choose whether you want to manage the nodes or whether you want to use the Fargate profile. Okay, I think the control plane you have to create it.
So in summary, it means like Fargate method is more an easier way to handle this stuff, eh?
It's more abstracted away, right?
Yes.
Yeah, that's right. Because
yeah, go ahead.
Yeah, so under this method, right now we saw two worker nodes, right? And so you have to make sure that when the number of workloads running in your cluster are increasing, you have to make sure that your worker nodes are scaling out, right? New nodes are going to be added to your existing group. But under Fargate, you don't have to take care of like scaling in and out your worker nodes, and like patching those. You also have to patch those, right? Like there are several certain maintenance activities that you have to do. So you can simply get rid of all those under Fargate.
Sean, very quick question. So it was interesting. I kind of understood why in a same cluster all the instance types are kind of same. But then you said like when it comes to two different clusters, those two clusters can have different types of EC2 instances, right? So my question is, usually,
not exactly. So I said right. No, I think you got it. I mean, you didn't get the exact message that I was trying to convey. So this is a single cluster, and when I go to compute, I have a node group, right? So I just have a single node group inside which I have two worker nodes. So what I said was, you can have another node group, right? You can have another node group with three nodes, but the type of those three nodes could be different from the type of these two nodes. So between the groups, the type of the nodes could be different, but within a group, the type should be the same as far as I remember. I mean, these are actually available in the documentation.
Yeah. Just a quick question. So the group, because I'm trying to understand some of these words. So so the group means same cluster. You can have several groups.
Yeah, several node groups.
Groups.
Yeah, so like let me give you a practical example, right? So let's say you have some admin services, like when inside a cluster, you have like two kinds of applications, right? So one category, the first category is business applications. So you might want to schedule all the containers related to your business application in your first node group, and you might want to schedule all the applications related to your admin services in another node group. So they are like at least logically isolated, right? So there's an increased isolation between your business applications and admin applications. You got it, like that's where these node groups comes into the picture.
Yes.
So likewise,
then I have a super dumb question as well. Then I have a super dumb question as well. Why not we have several clusters, like one cluster for one app, another cluster for another app? Is it like more expensive, or it's not kind of a good practice?
Yeah, in my view,
like you take the same example.
Yeah, in my view, it's going to be a little expensive, right? Firstly, and as far as the management and maintenance is concerned, also it's going to be an overhead, right? Because like you are going to have multiple clusters, and you just can't stick to this 1.27 version all the time, right? Because like all the time you will have to upgrade the Kubernetes version, and when you do the upgrade, like you'll have to upgrade like all your clusters. So even that is going to take time. And even inside Kubernetes, like there are certain features that allows you separation, right? Like for example, namespace is another feature which allows you to do logical separation of your workloads, and like you can have multiple node groups. But it's something depends, like it's something actually depends. So if you really want to like isolate your workloads,
so say like there could be kind of middle-sized companies with 2,000, 3,000 employees. I'm saying like I'm using that the size to kind of get an idea of their service. So do you think like still people would use the same cluster? Can there be such situations? Same cluster, different node groups and all?
No, I mean, I would say like depending on the scenario, right? For example, like let's just consider you have two environments, a UAT environment and a pre-production environment. So in that case, like you might be running one cluster for your UAT and another cluster for your pre-production, right? So when it comes to an upgrade, right, you will do the upgrade in the UAT environment first, and you will test everything, and then you will do the upgrade in the pre-prod environment. So likewise, right? So if you have like completely different applications, so definitely like you would go for multiple EKS clusters. So it's not the case that in a company that you are running a single EKS cluster all the time. It's not the case. So you will definitely have multiple clusters, but inside one EKS cluster, you might have like all the related applications running inside the same cluster. That's how it works. But there will be multiple clusters.
Okay, perfect. So that's a very good example. So now I kind of get how we kind of define clusters. So it's more like, say you have a stage environment, you can have your own cluster for there. Then you have a production environment you can have, because then benefits of having one cluster with different node groups is like it's way more, it could be cheaper, plus it is way more easier to kind of
it's easier to manage, right? Because you can put front end in one and a back end in the other, or some whatever groups.
Yeah, and also like the communication, right? So if you have, for example, right, if you have related workloads running inside the same cluster, they can easily communicate, right? But if they are inside two different clusters, then you might have to go through some explicit steps to allow or facilitate the communication between the workloads or the applications.
Yeah.
Perfect. Yes.
Okay. So let me just come to the application in the meantime. So now, right. Okay. So I have a folder for code. Okay. So this is a Java application, a Spring Boot based application. Okay. So now what I'm going to do first is I'm going to just deploy the application without any containerization. So first of all, I have to build the application, right? So I'm using Maven to build the application.
Yeah.
And so this is my application, and let me just show you what the application returns when it is run. Okay. So this returns.
I haven't done much Java, but I think I.
Yeah, this is pretty straightforward.
Checked what is Maven. It says it's a Java. It's fine, but I get the idea.
Maven is a build tool. Yeah, let me just explain. This is the application, right?
Yeah.
Okay, so let me say.
Is it like hello world? Oh my god, Python is so easy, right?
This output is from our demo application. Okay. So basically, this is the source code, and so so usually what we would do is like we would build the application, right? So once you build the application, the build process will output a deployment artifact. So here I'm going to build the application using Maven. So Maven is the tool that I use to build the application. So I can run this command Maven clean install to build the application. Okay, so it will take a minute or so. Let's see. So now Maven is building the application.
Compiling?
Yeah, it will compile. Yeah, and it says build success, right? And it generated the deployment artifact, which is a jar file. Okay. So
now I remember.
Yeah, so that is inside the target folder. So let me go to the target folder. Okay. Okay, hold on. So let me go to the target. So I have two tabs. And let me run the application. So now once you have the jar file, you can deploy the application in a virtual machine. So let's say this is my virtual machine, and I already have installed Java runtime, right? So this is the runtime. I mean, this is what I said earlier, right? So when it comes to containerization, you will bundle the application code and the runtime. But here in this case, the application code and the runtime are still separated, right? So this is the traditional approach. We have the Java file and we have the runtime separately. So you have to have this runtime, otherwise this will not run. And I'm running this application using this command java -jar, right? And then I have to provide the Java file name. I think it's simple as that. Okay. Yeah. So you can see the word Spring because I'm using Spring Boot as the framework for this Java application. Oh, it's failed to start. Why? Okay, I think I have run another instance of the application previously. Let me just stop it. Okay. Because before joining this call, I was doing some testing in this application, and there was another instance of the application running on the same port. So because of that, this is not started, saying that the port is already in use. Right? So I just killed that process, and let me just bring up the application again using the same Java command, java -jar. Okay, this time it should work, hopefully. Okay, it says the application is up, right? And the port is 8090. So now, I'm switching to the other tab, and let me try to invoke the application and see what it returns. So I can use a simple curl request to invoke the application. Curl localhost, right? And the port is 8090. Okay.
That means it would run
Yeah. So
the
this is the
.jar file, right?
yeah. So now now I have run
Depends
the
what you
jar
program
file.
to do, but yes.
Yeah, this is the output from our demo application. This is what I just programmed just a little while ago. Okay, so this is the traditional approach. So what I'm trying to highlight is we had the jar file separately and the runtime we had separately, right? Which is Java, which is installed in this virtual machine. So let's say if you are to if you are given a task to deploy this application, let's say you get the source code, so you will be running the build process by yourself using Maven to generate the jar file. And even when you have the jar file, you can't simply run the application. You have to spin up the virtual machine and you have to install the Java runtime. So that is something I already did using these commands. I'll show you. So before joining this call, I installed the Java runtime separately. So what is interesting about containerization is everything is bundled to one Docker image. So when it comes to the deployment, you don't have to worry about finding all the dependencies, runtimes required, and installing them, because everything is bundled already to a Docker image. So your deployment process is very fast and efficient, and also it is consistent, right?
So where do we create the Docker?
Yeah.
Like
Okay, I haven't come to that part.
Because okay.
Okay, let me come to that part. So I haven't come to the Dockerization yet, but what I'm trying to say is, right, so here in the virtual machine, I have installed the Java version 1.8 because I know for this application to run, you have to have the Java 1.8 runtime. But if I simply share this application, let's say if I share this application with you guys, you guys can't simply even set up the Java runtime, right? Because you will want to know the exact version of the Java runtime also. So what is interesting about Dockerization is you can bundle the exact dependencies. So it's going to be an error-free, not error-free, but you will have minimal errors and it will be very consistent. Okay. So now we saw how we run the application without containerization. Let me just stop this process. Okay. Okay. And now let me do the Dockerization, Shaman, to answer your question. Okay. So Dockerization or containerization. So what we do is here. Okay. I have a directory for Dockerization. Okay. And I have already copied the jar file that I used to bring up the application to this directory. Okay.
Yes.
It is the same jar file that I used just a little while ago to run the application. Okay, not the same jar file. Let me just remove it because I put a custom message, right? Okay, let me just remove it.
But it's fine. Fine.
That's okay. Let me just quickly do it. It should be under code, test apps, target, template, jar here. All right. So I have the updated jar file. So I have to have a Docker file to Dockerize the application. Okay. Let me open up this Docker file and show you the contents. So I have the same. Okay. Is it okay if I just use this screen, or maybe let me just use.
I have this. It's okay.
Okay.
That's all.
Okay. So here I'm starting from. Okay. So here I'm starting from a base image. So in this base image, the Java runtime is already set up. So Amazon Corretto 8 is
Amazon Corretto?
Yeah, so this is the AWS version of JDK, Java, and the version is 8. So this is a Docker image which is available in the Docker Hub. Okay.
Okay.
And
so basically,
there are
yeah,
other ones. There's Ubuntu latest. There's a bunch of deep learning AMIs and a bunch of other images you can just copy and.
So in a way, an AMI is also a Docker image, or not?
Not exactly. So we use an AMI to create a virtual machine, right? So similarly, we use a Docker image to bring up a container. The process is the same. Okay. So AMI, so be it AMI or be it the Docker image, that's your underlying contents. But you use it to create an instance. That instance could be a virtual machine or a container.
Okay, got it.
Okay.
So idea is same as AMIs. You have this kind of pre-built Docker images where you kind of can use and start from them. Like so, you don't have to worry about all these basics, eh?
Yeah. So I'm actually going to create a Docker image.
Right?
I'm going to create a custom Docker image because I want to create a custom Docker image for this application. So this is where I'm bundling the runtime and the application. For that, I'm using a Docker file. But let me show you how this works. So I have started with a base image. So we usually call it base image. So in the base image, we have the Java 1.8 version, the runtime. It's already there in the base image. And then I copy this jar file to the base image, and I have some other commands like exposing the port, and this is the startup command. Okay, so I have to use this Docker file. I have to execute this to create a Docker image. So to do that, there's another command. I have to use this Docker build command. So let's say this is I'm using this command docker build. So once I execute this command, what happens is this is going to create a custom Docker image. Now this custom Docker image will have the Java runtime plus the application. So that is where I do the packaging. And Docker runtime is.
So just a quick question.
Yeah.
So the Java runtime comes from the base image, eh?
Yeah, that's right. And I use the Docker file to add the application's deployment artifact to the base image. And this build command will create a new image. So that is not the base image. I would call it a custom image. Okay. So for example, now when I run Docker images, so Docker, I have already installed the Docker runtime in this virtual machine, and that's why when I run the Docker images, it returns me this output. So I have my app version 2, right, which is what I used just now. My app version 2, created 44 seconds ago, the one that I created just now. So this is the custom image. So what I'm trying to highlight here is, right, so if you guys want to bring up this application, all I have to do is simply share this Docker image with you guys. So if you have Docker runtime, yeah, you don't need the jar file or anything, right? Because everything is bundled inside this Docker image, inside this custom Docker image now.
Yep. So the jar file is in there as well.
Yeah, jar file is there, the runtime is there. I mean, this is a very simple scenario, right? But in an actual use case, there will be other configurations, like there could be different runtimes, right? All these are bundled together.
Yeah.
Okay.
Can you open this Docker file? No, right? No, it's like a compact file, right? If you use it's not like.
No, we can't open it, but
doesn't
we
show
should be able to.
You can open, but not the image, right?
Yeah.
We can't open the Docker file. Right? No, yeah, Docker file we can open. Docker image we can't open, but we can inspect the Docker image. But let me show you, right? Docker inspect, and we have to provide the image ID. I believe it's correct. Let me just see. Yeah. So once I inspect, it shows me the contents of the Docker file, right? It's my app v2. This is the name that I entered, right? And this is the version. And like the host name, like it's a little complicated, but there are still useful pieces of information that we can grab from this still.
But we get the idea, yes.
Yeah. So still what I'm trying to highlight is still no application instance is running. Application is not up yet, but we have the image.
Yeah.
So now how we have the Docker image, the next step is to bring up the container using the underlying Docker image, right? So no Kubernetes yet, no orchestration yet. So we have a command called docker ps. So this shows no Docker processes are running. Okay. And if I run curl, I think you guys are familiar with this command, curl localhost. Okay. So nothing is running on port 80, right?
Sean, very quick question. Don't we need to use something called Docker Compose Up or something?
It's not necessary.
Coming up next, maybe.
Yeah, so Docker Compose is actually so let's say when you have like multiple containers, right? Now in my case, I just have a single container. But let's say in an actual setup, you might be having one container for your front end, another for your back end, and you might want another container for your messaging infrastructure, right? You might want another container for your database. So all these containers you can just simply bring up all in one go using Docker Compose. That's more like a feature, but this is the underlying or fundamental concept. So once you are clear with this, Docker Compose is something very easy to understand.
So Sean, very quickly. So Docker Compose Up usually can run even with the Docker file, right? Or do you need to do convert it to the image prior to that, or Compose Up does everything and boom, set everything up?
Okay, so I mean, from what I understand, so definitely Docker Compose Up is used to bring up the containers, right? So as we discussed just now, if we are to bring up the containers, we have to have the underlying Docker images, and the Docker images comes from the dockerization process from the Docker files, right?
Yes.
But what I'm not very sure about, or what I don't remember, is whether the Docker Compose also takes care of building the Docker images using Docker files. But it definitely spin up the Docker containers from Docker images. But the first part, I'm not very sure. I can't remember actually. But that's definitely something definitely we can understand. Okay.
So it's so I just Google is the first question comes. So it says compose pulls a Redis image, builds an image for your code. Yeah, seems like does Docker Compose build images? Unlike the Docker file, the Docker Compose command and the docker-compose.yaml file, the command depends upon are not used to actually build Docker images. Yeah, it says.
Yeah, it is used to
seems
spin
like
up,
we
right?
need containers.
You have to have the images. Once you have the images, you can use that. Yes.
Yes.
Okay. So here we also created images, right? And so instead of using Docker Compose, we are using another command called docker run, right? So still no application is running here, right? And now here I'm using okay, this is what I do, right? Let me just clear this. Okay, so now I'm going to use this particular Docker image, my app version 2, to spin up a container, right? So for that, I will use this command, docker run. So minus d instructs Docker to run the container in the background, right? And if you guys remember, port 8090 is the port that application is listening on.
Yes.
And that is mapped to the port 80 of this host server. So because usually we open up the HTTP connections on port 80, right? And so let me run this command.
Wait, so the left is the host machine or the right is the host machine?
Left is the host machine, right is the container.
Okay.
And now when I run the docker ps command, I can see a container is running. So now only the container is running. So this is the actual application which is running from this image, right? And created 11 seconds ago. And in the host machine, port 80 is mapped to the port 8090 inside the container. And there's a random name. So now we can run a curl request and see if it works. Curl HTTP localhost. I'm not going to mention the port because by default the port is 80, right? I can even mention it. Let me just get rid of the port because by default, if you use localhost, it will be directed to the port 80. And now I can see it. This output is from our demo application. But this is coming from our container now, right? So,
understand?
yeah, clear, right? Clear so far?
Cool.
Yeah, it's clear.
Yeah.
Oh, okay. Yeah. Now this is a single application, right? So what if I want to run 3 instances of the same application, 3 containers? It might be useful, right? So let's say I have an application which should handle a heavy traffic, and so what if I want to inject some scaling features to the application? Let's say at night, just a single instance of the application would serve the traffic, but during the peak hours, I have to have 4 instances of the application, right? And so what if I now this is running inside my virtual machine, right? So once you have like multiple instances of the application, you have to load balance the traffic, right? So there should be a load balancer in front of your application, and so you might be rolling out new versions of your application all the time. So let's say next day you just improve your application and you will be rolling out the application. So during the rollout, you might want to handle the rollout gracefully, right? So there won't be a downtime of the application. So these are some of the features Kubernetes provide as a container orchestration technology. Okay. So now what we do is let's run the application inside the Kubernetes cluster. Okay.
Okay.
All right. So let me first stop this Docker image. Okay. I have to run docker stop. The container ID. It's not necessary to use the full ID. So I stop the container and I remove the container. Okay. So now when I run docker ps, no container is running, right? And when I run the same curl command, now it doesn't return any response because the application is not running. But we still have the Docker image. We still have the Docker image, right? I can use it anytime. Okay. All right. So now let me come to the Kubernetes part. First of all, to interact with Kubernetes cluster, there's a tool called kubectl. Okay. So I have already installed kubectl. Let me show you.
Okay.
Kubectl. So this is just a command line tool. I have already installed that in my workstation. Okay.
Yeah.
Okay, so I created the folder called. Let me come here. Okay. So first of all, I have to authenticate with the Kubernetes cluster, right? So what I'm trying to do is
with the
let's
cluster,
say,
not just AWS.
yeah, not just
first, I mean, if you were doing it from scratch, you will have to authenticate with AWS and then with the cluster as well. I guess.
Yeah, exactly. Because I've already authenticated with AWS, right? So I can use this command AWS get AWS STS. It's a little so slow. STS get call identity. Okay, so this is to validate if I'm already authenticated with AWS. Yes, I have already authenticated with AWS, right? Okay,
this is
now,
IAM, right?
Sorry, come again?
Is it IAM? Like
Yes,
authentication?
yeah, exactly. Yeah, according to the IAM user that I created earlier, now I'm authenticated with the AWS cloud. Now this guy should be able to, now I should be able to communicate with the cluster as well, right? So to do that, okay, there's a file. Let me show you. Okay, let me just remove this file because this file is from the previous cluster. Okay, I have to use this command. Let me explain to you what this does. Right, the command is AWS EKS. So this AWS is coming from the AWS CLI, which is I have installed the AWS CLI in this virtual machine. Update kubeconfig, and this is the cluster's name, Terraform EKS demo. So if I just go back to the EKS cluster, Terraform EKS demo, right, which is the cluster's name.
Yes.
And this is the region AP Southeast 1. So I'm inside Singapore region. Singapore is actually AP Southeast 1. Okay. So once I run this command, okay, it says added new context to root kubeconfig. So this is the file that is created. Okay. So if we actually open up the contents of this file, we would see, according to this configuration file, now the authentication to the EKS cluster is set up, right? Now, for example, I can run a kubectl command, kubectl get nodes. So I can see 2 nodes. I believe earlier we discussed, right? We have 2 worker nodes in our cluster. So see the IPs. 10.0.2.127, 10.0.3.241. So if I go back to the AWS console, right, to the EC2 section, and if I just cross-check the IP addresses of those 2 EC2 instances, they are the same. Let's just do a verification in one node. See the IP 10.0.3.241, 10.0.3.241. This is one node, right? And then this is the other node. And let's see what are the workloads running there, right? So we can use this command kubectl get deployments, and in all namespaces there's something called namespaces, but we don't have any. This is the DNS related service that I described earlier. So this is not something that I created, right? But there's a deployment that is actually used to handle DNS in the Kubernetes cluster, which is already there. Okay. All right. Now we have to create a deployment. So when I say deployment is actually the containerized application. Okay. But before that, now the Docker image, right? Docker image is in my local machine, right? So this is the Docker image that we want to use, but it's in my local machine.
Yeah.
But so inside the EKS cluster, the deployment will actually use the Docker image, right, to create the container. But how does EKS cluster is going to read this Docker image which is in this virtual machine? It's not possible, right? It's something that we can make possible, but for that purpose, I am using a container registry in AWS. I already included that in the Terraform script. So AWS has a service called Elastic Container Registry, which is a Docker registry, similar to Docker Hub, right? Where you can store Docker images. Okay, I think I will have to use the same term. Let me just let me go show you, right? Yeah, so this is the Docker registry that I have created. So this was also created by the Terraform script, right? See, at 1850.
Yeah.
And inside this Docker registry, we don't have any Docker images yet. Okay, now what I'm trying to do is I'm going to push the Docker image, which is in my local virtual machine, to this Docker registry. Then it is accessible to the EKS cluster, right? So similarly, like once I push it, like even you guys can retrieve it or pull it from the same registry. That is one way of sharing Docker images from your local machine with someone else. Okay, so to do that, these are the commands that we have to use, right? First, you have to kind of authenticate with the registry. Okay, this is where I authenticated. And once you're authenticated, these are the steps to push it, right? There's a tagging that we have to do. Let's say this is version 2, my app version 2. So I'm going to tag it. So now when I run Docker images, I have a Docker image similar to the existing my app version 2, but that is tagged after a different name.
Mm-hmm.
But this is actually the endpoint of the Docker registry that I have in the AWS cloud. And the
so
final
it's a
step
remote.
is, yeah, that's right. The final step is I have to push it. So let me push it. And this is the version 2. Yeah, so now it is being pushed to the AWS Elastic Container Registry. Clear so far?
Yeah.
Yes,
So the
perfect.
images are usually hundreds of megabytes.
Yeah, that's right.
Docker files are usually quite tiny, right?
Yeah. Yeah, it also depends on the base image. So I started with one of the Amazon Corretto image, right? But there are very lightweight images also. Okay, now we should be able to view the Docker image right under this registry. No images. So when I refresh it, yeah, so we have it here. Right. All right. So now we come to the final part of the demo, where we do a Kubernetes deployment. So okay, let me run kubectl get deploy. There are no deployments in the default namespace. Okay, kubectl get service. There are no services. So I'm going. Yeah, there's just a single service, but this is a default service. So I'm going to create a deployment and a service to expose the application to public, right? And the service will be of the type load balancer. I mean, that is a concept of Kubernetes, which I'm not going to dive into like describe that in detail. But I just want to show you that as of now, currently, we don't have any load balancers in our AWS account. Okay. And okay, this is how we do the Kubernetes deployment. Okay. So firstly, we have to have something called Kubernetes manifests. Okay, so let me show you. Okay, so this is for the deployment. So this is the manifest that represent the deployment. So this is how we interpret it. So this is this is written in YAML, and this is actually understood by Kubernetes. So I'm saying I want 2 instances of the application. So this is where high availability comes into the picture, right? And I want to allocate 900 milli CPU, and this is the container port, and this is the Docker image, underlying Docker image. So here I'm saying the container or the pod should pod should be started up using this underlying Docker image, which is already in our ECR, right? And this is how we control the updates. So for example, right, I told you like when we have to roll out a new version of the application, we also have control over it when we use Kubernetes. And if we want, I can.
So it's based on the CPU usage.
No, like what I'm trying to say is like let's say after 2 months you are rolling out your version 2 of the application. So if you have 2 replicas of your application running, and during the rollout, like you are going to roll it out in a way that there's going to be no downtime. For example, right, you have 2 replicas, and both these replicas are both these replicas corresponds to version 1.
Okay.
And you will have the third replica, which is spin up by pointing to version 2, and then you will kind of decommission one replica that belongs to version 1. So it will be something graceful. So I haven't integrated any scaling features, but if I want, I can even integrate scaling features to this deployment, and I can even integrate auto recovery features to this deployment. So all these are features of Kubernetes, or generally all these are features of container orchestration. Hope
Yeah,
hope
but
you guys are clear, right?
I still yeah, I have a question. Like I still didn't understand the max search and the win unavailable 25% thing.
Okay, so let's say, for example,
So
right, you
that's
have,
when you're going from V2 of the app to V3 app, right?
yeah, so let's say you have like 10 replicas running, right? And so during the switchover, right, you are like your application version is switching over from version 2 to version 3. So during that change, you can just have a 25% of unavailability in your application instances. I mean,
Wow,
high
you
level,
can even
that's
change that.
how, yeah, that's how we
So the
interpret it.
idea is not idea is we don't shut down everything, but
Yeah,
some of them, then we kind of update them, then goes back to the other stuff, eh? So like, you goes in between. So
yeah,
you don't
exactly.
just shut down everything in the same time. Wow, that's pretty cool.
Yeah, but let me just take a minute to show you how scaling works here, right? I think it's something important. I will not integrate it, but I'll just show you. Okay.
Yeah.
Let me quickly do it.
There was this auto scale thing.
Yeah, I'm going to show that. No. So this is a feature of Kubernetes scaling, right? So if we use plain Docker, we won't have all these features.
Yeah.
Yeah. So this is a manifest, right? So we can use a manifest like this. I will not use it like here, but we can define, right, what is the maximum number of pods, what is the minimum number of pods, and what is the condition
Yes.
upon which the scaling should happen. For example, right, we can say
Yep.
always the CPU utilization should be maintained at 70% or at a rate below 70%. So let's say we have two pods and the CPU utilization is like 75% and 72%, let's say. So now Kubernetes will make a decision. Okay, I have to keep it under 70%, so I have to add another pod to the deployment. So it'll bring up another pod. So there'll be 3 pods now, and the load distributes between 3 pods compared to 2, and the CPU utilization falls below 70. I mean, that's how it works. Okay, so let me use this. Okay, let me use this to spin
And
up
can
the
you use
application.
other stuff as well, like, I don't know, API request or some other metrics for that as well? Or CPU is the main, CPU and RAM is the main?
No, we can also use other CPU and RAM. Yeah, so they are the default matrices, but we can also use custom matrices. But for that, we have to do some instrumentation, application instrumentation sometimes.
Okay.
For example, let's say based on number of pending jobs in a queue, for example, let's say, right? So let's say your application serves some queues.
Yeah.
So Kubernetes should know the count.
Okay.
So you have to like kind of feed in those to Kubernetes. Yeah, that's where some explicit instrumentation comes into the picture. Okay, now
Okay.
so I already have this deployment YAML, right? So let me make it 3 replicas, right? Let me make it 3, and so this is the same file that I showed just now in my code editor. Okay, and so there's a command called kubectl apply deployment. Okay, now the deployment is created. So how do we know? We have to run a command called kubectl get deploy, the same command that I ran earlier, right? So now I can see I have the test app deployment, and there are 3 pods, 3 instances. Okay. So the difference between pod and container is like in Kubernetes we have something called pods, and inside a single pod we can have multiple containers. I mean, that's how it works. And according to this
like
file,
inside a pod you can run Docker. like
inside a
several
pod you can run
containers.
multiple containers. Yes. So here like I'm just running a
Yeah,
single
okay.
pod. So usually we run a single container inside single pod. So here I'm running a single container inside the pod, but I have three pods, right? For the high availability I have three pods here.
Okay, so but we have three pods, yes, and each pod, if we want, we can run multiple containers. Like there could be some applications like kind of a Docker image or something which could need several different containers. So you kind of can execute. That's what you said, right? Inside a
Yes,
pod, there could be
we
multiple containers running.
yeah, we have
No.
that capability, but I haven't implemented that. But let me tell you an example
Yeah,
scenario.
it's okay.
Yeah, so let's say we have our
Yeah.
application, and we want another like supporting application to ship our logs, like to collect the logs from our main application and ship it to somewhere else, let's say to an analytics platform. We were here, right? Demo. Okay, so we just deployed the application, right?
Yeah.
Okay. All right, cool. It's running. So we just deployed the application, and so there are three instances of the application which are running. So we can confirm the same by running the kubectl get pods command. So there are three pods running. So this shows inside a single pod there's a single container. Shami, to answer your question, right? Like if you have like multiple pods inside this, multiple containers inside a single pod, then this value would be different. Okay. So now we have to expose the deployment. To expose deployment, we are using another manifest type called service.yaml, and the type we are using as a load balancer. Okay, and let me just apply the service. All right. So basically, right, this deployment we have to open it up to the outside to users on the internet through a load balancer, and for that I'm using the service manifest.
But can you show the service manifest again?
Okay.
The code.
Yeah. Okay. So this is it.
So that's just expose imports type thing. Okay.
Yeah. So I'm saying like I'm using the selector app test, right? So this is where I'm kind of linking this service with the deployment. So even in the deployment also I have the same tag. So what happens is, let's say Ravindu wants to access the application, right? So when you send a request, it is the service that is going to pick your request up first, and service will forward it to the application, which is to the deployment level, right? The one that we created earlier.
Yeah.
So there are three instances of our application, right? Three pods. So service will actually load balance the traffic across the three pods of our deployment.
Yeah. Okay.
Okay.
Yeah. And test is the name of our application, right?
Test. Test service, right? The name of the service is test service.
The app is.
Yeah, this is more like a label. So if I open up the deployment YAML file, right, I have the same label. So this is how the service will actually forward the traffic to any deployment which has these matching labels. That's how it works. As long as the labels matches, the service will forward the traffic. Okay, now what I want to show you is the service. The type of the service is load balancer. So if I go to the load balancer section, yeah, now I have a load balancer here. Okay, hold on. I have a load balancer here, and let me just go inside the load balancer. So this load balancer corresponds to the service that I just created, and this load balancer is forwarding. Yeah, so this is forwarding traffic to the true worker nodes actually, according to this, I think.
Yeah.
Right, and there are three instances of application. Now we can use. So this is a public load balancer. This is an internet-facing load balancer. So I can use this DNS name. Now I don't have to like run a curl request inside my virtual machine. So now this is available to public. Like now if I run HTTP, right, and the load balancer domain name, yeah, our application is accessible from the internet. Like I can even share the same link with you. So just give it a try. It should be accessible. Okay, how to share that? Let me just share it over the chat. Just see if it is accessible.
Chat thing.
Yeah. Just use HTTP :// in front.
Yeah.
Yeah, it works.
Cool. It's accessible, right?
This output is from one.
Yeah. So now, So this is now here. The application is running inside the Kubernetes cluster using the features of Kubernetes. So one feature I'm utilizing is the high availability, right? To run 3 replicas of the application. And similarly, like we can make it feature rich by incorporating the scaling, like controlling rollouts. And I even use this load balancer feature of Kubernetes. So these are the features of Kubernetes or a container orchestration platform. But I mean, just to highlight, right? So in AWS they have another container orchestration platform called ECS, not EKS. ECS stands for I think Elastic Container Service, but that's a proprietary platform in AWS. It's not open source like Kubernetes. Yeah. So
but that gives you similar features as well.
Yeah, that gives us similar features, but they are defined slightly differently. For example, right, to control the scaling in Kubernetes, we used horizontal pod autoscaler, but in ECS we define it slightly differently. It's not the exact same horizontal pod autoscaler feature that Kubernetes provides you, but it's a different feature that ECS provides you. So because that's a different orchestration platform. But all they do is like just running and hosting containers. So in my second stage, right, I simply started the container without any orchestration. So if you can get to that stage, after that you can just go ahead with any orchestration platform. So Docker Swarm is another orchestration platform. So we have like different orchestration platforms. Docker Swarm, it could be ECS, it could be EKS.
Okay.
So this is more like a 3-step process. Like personally, that is how I see it.
Yeah. So like like we kind of had a very nice session, and I mean I personally learned a lot because I'm kind of a newbie to this, and it just like sometimes for us, although we apply this stuff, it's we can't just go in depth with this stuff, but because with the time and with the other work as well. But this is really good. I kind of get an idea of what is Terraform, and then more like how can we code something with it, and as well as then how can we use it to kind of create these instances or clusters and all. Then also we learned about what is Kubernetes, and why it is important, and plus the bonus was the orchestration part, which I really like. And so thanks a lot, Sean. Really appreciate it. And so
joining you guys.
I'm I think we should do these kind of things few more often, more like ML ops, like kind of a thing. Like Sean, you might have heard of ML ops, right? It's like DevOps, but mainly for machine learning.
Yeah, definitely. Yes.
So yeah, there are pretty much kind of I would say intersections in these two fields. So yeah, Ravindu, do you want to add some closing notes?
No, it was really useful because I get a better idea. So after you did this, the deployment part, like you'd use something like GitHub Actions to do all that packaging up of the jar file and then deploy it, and then everything is automated, right? That's the whole DevOps.
Yeah, so usually, most of these
Yeah. So it's
steps are handled through the automated pipelines, but I just manually did for the clarity. Like it's actually good to understand what is happening under the hood, like before we just do something using
yep,
automation.
yep,
Yeah,
yep,
Yes. Uh, all right. Yeah, we'll call it a day because it's already like almost like 2 hours. So thanks a lot, Sean, and
yep.
we are going to stop the recording. That's a
yeah, it
one
was
way
my
to
pleasure, Journey. Thanks a lot,
like
guys.
end the session. Bye bye, and please subscribe and like our videos.